Before I get started, can you please let me know whether you can hear me loud and clear and you can see my screen as well?
Yes,
Yes,
yes.
sir. We
Yes,
can
sir.
hear
Yes,
you
yes.
and see you, sir.
Perfect. So today's topic is on basic statistics. Before we jump on to machine learning topics, it's essential that we have to understand some of the important fundamental concepts of statistics so that we can follow the basic statistics topics and the machine learning topic clearly later on. Okay. Let us understand what exactly are these basic descriptive statistics. The fact is, everyone in this classroom already know what are descriptive statistics. Only thing is that we do not know what are the technical names. The technical jargons, we are not aware of them, but we exactly know what are descriptive statistics. For example, if I give you the data of income of around 1,000 individuals, I have given you monthly income of around 1,000 individuals. And if I ask you to prepare a summary report, I don't want to print this whole 10,000 records. I want to prepare a summary report. If I ask you to prepare a summary report, in that summary report, what measures or what numbers you will represent? What will you put them here? Think of it. What all numbers? Send me a message. What will you include in this summary report? Everybody, think about it. You will put average income. That is one, isn't it? You will put minimum income. You will also include maximum income, isn't it? This average income is known as measure of central tendency. Minimum income and maximum income, they are known as measure of dispersion. May not have heard measure of central tendency, measure of dispersion, but you have already used them. The descriptive statistics are those numbers or those metrics that will summarize the data. They are measures of central tendencies, measures of dispersion. They explain us about the data without actually printing the whole data. So let us see what exactly are measures of central tendencies, what exactly are measures of dispersion. Let us talk about the first measure of central tendency, that is known as mean or average. It is known as arithmetic mean. What is the formula for mean? All of us, we have already used it. What is it? Sum divided by count. If you have to write it technically, how will you write it? X bar is the symbol. Summation of xi divided by n. That is known as mean. I don't think we have to discuss a lot about mean. All of us, we have already used mean, isn't it? If you have to calculate mean in Python, how do we do it? Let us see. This is our first data set we are going to use in the lab exercise. There's a data set called census income data. Census income data, there is one CSV file called income underscore data.csv. This is the 1990 USA census data. In this data set, there is a column called capital gain. I want to find the average value of capital gain. So how do you do that? You write the data frame name. So we import this data into a data frame called income, and we write the column name dot mean. This will directly give us the mean value, and then we store it in a particular variable. We can print it, or directly printing is also possible. So this will be our first exercise. These code files are stored on a Google Classroom. I'm going to give you the Google Classroom link. Somebody can paste that Google Classroom in our WhatsApp group. As of now, I'm going to give this Google Classroom link in the Zoom chat here. Okay. So I kept the Google Classroom link in the Zoom chat window here. Especially those who are not present in the classroom. If you are watching this video, maybe you have to go to that particular WhatsApp classroom that you are part of. Please try not to send a message whenever you are watching. asking for the classroom link. Maybe those who have the classroom link try to help others, okay, later on, because I have seen that continuously for the next 1 month, I keep on receiving the classroom links request. Try to help me by spreading this, okay? This is the Google Classroom link. Go to that classroom. All of you, do you already know how to use the Google Classroom? You know that, right?
Yes, sir.
Perfect. What I want you to do is go to Google Classroom. In that classroom, go to classwork. In classwork, you go to the first topic, basic descriptive statistics. This is the topic. Click on the topic name and then descriptive statistics code version 1. This is the Colab file. You can directly paste the Colab file link also in the chat window. If you directly click on that Colab file link, you'll be able to land on this. There are two ways of practicing. One is you practice on Jupyter Notebook, or the alternative version is Colab. I think in Python classes, you have used Jupyter Notebook. That is how in the real world scenarios, the Python projects are executed. We generally use Jupyter Notebooks. But here I'm going to use Colab because later on in several other algorithms, we may need a little bit speed. That's why we are using Colab. But both of them are notebooks. You consider this as Python notebook file. So if in an interview somebody asks you, where do you do code? Generally, nobody asks that. So what will be your answer? Are you going to say Colab or Jupyter Notebook? What is the right answer? Usually in the projects, we use what? We use Jupyter Notebooks. Okay.
Jupyter.
Yes. Jupyter Notebook is what we use in the regular projects. But anyway, it's a notebook. What I want you to do is import this data set. Maybe you can look at number of rows, number of columns. But what I want you to calculate it, what is the average capital gain value? So go to mute and send me the answer for this capital gain in the chat window. Average capital gain value. What is the average capital gain value? Some of you are pasting 1077.6488. Verify this, everybody. Everyone needs to paste their answer in the chat window so that I get to know that all of you are on the same page. While executing this code, is there anyone facing some issues, not able to open the code file, not able to execute the code file, getting some errors, any issues, anybody, please quickly let me know. All right. Now that is pretty straightforward, isn't it? We have found the average capital gain value 1077.6 something. Now, if I ask you a question, the question goes like this. Listen to this carefully, all of you. The question is, what will be the average monthly income of a person in India? If I take whole India from east, west, north, south, whole of India, and if I take everybody's income, if I find the average monthly income of a person in India, how much do you think we will get right now in the current scenario this year? If I take it roughly monthly, how much they will be getting monthly income, everybody in India? Some people are saying maybe 15,000 per month. Some of you are saying it is around 40,000 per month. Everybody is earning like 40,000. Some people are saying 5,000 to 7,000. Maybe right, maybe wrong. Yeah. Some people are saying Pankaj Sharma 1 lakh monthly income. Are you sure? Definitely not, isn't it? At least think about it. A little bit you have to think when you're answering, isn't it? Otherwise, the person who is recruiting you, they will get to know that you have, not basic general knowledge. Okay. Around 25,000. Somebody has sent 0. See, if you do not know the answer or if you don't want to answer, just stay quiet. If you're saying average monthly income of a person in India is 0, anyway, okay. Okay, these are some of the answers that we got. What if we find the average income of a person in India? That comes to be like somebody told that 1 lakh or somebody saying 75,000. What about others? Do you believe this is correct? 75,000. Everybody in India right now, they are earning around 9 lakhs per annum. 9 LPA is the package for everybody in India. East, west, north, south, rural, urban, people living in hill area, people living here and there. Do you believe in this? Is it possible? Unanimously, everybody is saying this is impossible, isn't it? 9 lakhs per annum on an average, everybody earning this. Impossible, isn't it? Even if we have little common sense, because we live in India, right? We see the situation outside. It's impossible that everybody is having 9 lakhs per annum package. If we take every Indian, let us see how average is calculated. How average is calculated? In the numerator, we put everybody's salary. My salary, your salary, everybody's income. Along with all of us, there's a person called Ambani. His income is also added. Along with that, whenever you hear Ambani, there's one more guy who comes to our mind. Who's that? Adani.
Adani.
His income also we are adding. And so on. Everybody's income is in the numerator. Tata and all of them. In the denominator, everybody will be counted as 1. How about Ambani? Is he counted as 1 or 10,000? Ambani is also counted as 1. Everybody is counted as 1. Maybe my income is in thousands. Maybe your income is in thousands. Maybe someone else's income is in lakhs. What is Ambani's income, monthly income? 30,000 crores. What is Adani's income? Roughly around 45,000 crores per month. Now in the numerator, if you see here, in the numerator, you have huge numbers. In the numerator, you have some numbers that are very, very far away from the rest of the values. And in the denominator, you still have same number 1. Because of those values, the overall mean seems to be a really high number. In fact, if you calculate mean value, if you take mean value of the monthly income, you may get this much actually. What is the reason? Because in the numerator, you have some values that are very far away from the rest of the values. In technical terms, what are these called? There are some numbers in the data that are very far away from the rest of the values. What are they called?
Outlier.
They are called as outliers. When there are outliers present in the data, can you really trust the mean value? Is it fair to say mean is heavily influenced by outliers present in the data? When there are outliers present in the data, outliers pull the mean towards them. Let's take another example. If I have this data, if I try to find the mean value, I think if I just guess it, somewhere around 1.5 or 1.4 will be the mean value. But to my surprise, when I calculate the mean value of this data, I got the mean value as 2.5. The mean value of this data is 2.5. Can you tell me why is so that? Why the mean value of this data is 2.5?
So we have 9.
Because there is one. Because there is one. What is this called?
Outlier.
There is one outlier. So if you look at this data, can I say 90% of the data is less than 2? Is that a right statement or not?
Yes.
Can I say mean value is 2.5. One side I'm saying 90% of the data is less than 2. On the other side I'm saying mean value is 2.5. Don't you think these two statements are contradictory?
Yes, sir.
Why is this contradiction happening?
Because of
Because
the
of
outliers.
Because of outliers. So is it fair to say in presence of outliers, my mean doesn't really represent the true center? I cannot always blindly take mean and think that that is right at the center. Especially when there are outliers present in the data, mean doesn't represent the center. There has to be some other center, or there has to be some other average. That new average is median. Median is also an average. It is alternative to mean. How median is calculated? You take the original data, then you sort the data. This is sorted data. After sorting, whatever is right at the middle, that is called median. That means 9 was an outlier earlier. Instead of 9, if I have 99 now, what will be the new median? Will it be 1.4 or 14? If you have 99 here,
14.
14. Will it be 14?
1.4, sir.
1.4. What if it is 999? What will be the new median?
1.4 only.
Even if it is 9999, what will be the new median? It will be still same, isn't it? Think about it, everyone. Especially those who told 14. What will be the median instead of 9 if I have 99? Do you agree with me now? It is still 1.4 only. How median is calculated? You just sort the data. You just take the middle number, whatever is in the middle. That is called median. Even if you have 999, the median is same. Is it fair to say median is not influenced by
Outliers.
outliers? So median is an alternative average which is not influenced by outliers. Now in conclusion, how do you use median in real life? Let us see. How do you use median? Tell me honestly, if somebody tells you, hey, calculate the average value. Until now in our life, what do? When somebody says average, simply we calculate the mean value. Yes or no? Do you agree?
Yes, sir.
When someone says,
Yes,
hey,
sir.
calculate the average, we simply calculate the mean value, consider that as average. But from here on, what are you going to do? You will calculate mean. But immediately after that, what you will calculate? After calculating mean, you have to calculate median. If there's a huge gap between mean and median, if there's a huge difference between mean and median, what does that mean?
Outlier is there.
There must be some outliers present in the data. When there are outliers present in the data, can I trust the analysis?
No.
No, sir.
Outliers have some impact on the final results. So we need to do a drill down. We need to identify outliers. We need to clean the data before going into analysis. Do you agree with that? Or can we directly go ahead with outliers? Oh, we have to clean the data. All these steps I'm going to explain you in some time. As of now, have you understood a hint for finding outliers? What is the hint? You look at the mean. Immediately you calculate the median. If there's a huge difference, 1 or 2% difference, that's okay. But if there's a huge difference, then you know that there are some outliers. For example, just now you calculated the mean for capital gain. How much was that? 1077 something. Do you really believe that 1077 is right at the center now? Can I give guarantee? Is
No,
always this mean value right at the center? No. How do you confirm that? Tell me, how do you confirm that? By calculating the median value. If median value is also 1000 or maybe 1100, then I would say, yeah, this is right at the center. Go ahead, calculate the median value. Go to the code file, calculate the median value. Tell me what is the median value. All of you go to the code file, calculate the median. What is the median value? The median value is 0. Is that true? Can somebody else verify that? Everybody verify in your system. Is median 0? Mean value is 1077. Median value is 0. What does that mean? What does that mean? It means, tell me, mean is 1077. Median is 0. What does that mean? As a data scientist, what do you infer from here? There must be some outliers present in the data. When there are outliers present in the data, we need to drill down. We need to identify what percent are outliers. Yes or no? We need to identify what percent are outliers. We need to clean the data before doing the analysis. Do you agree? We are going to see
Yes, sir.
all these steps later on. As of now, we will get a small hint that there must be some outliers present in the data. First of all, are you comfortable with this code, all of you? Is this syntax? Can you follow this syntax? All of you completed Python, right? Basic
Yes, sir.
Python. It's pretty straightforward. We are just directly
Yes,
using the
sir.
functions. You must be able to follow this, okay? If at any point of time, if you're not able to follow this, let me know. I'll explain this. It's directly like it's your data frame, column name, the function for mean. Data frame, column name, the function for median. Pretty straightforward. Mostly in machine learning, we'll be using all the ready-made functions. So you will not really have a big challenge in writing or understanding the code once we know basics of Python. A lot of people get afraid of Python, but the real usage of Python is very, very minimal in data science because we will use the ready-made functions. That's why. Let's take a pause here and take some questions. If anybody has any questions, please let me know. Until whatever we have discussed.
Sir, on which column basis this mean is calculated? Because when we like print the income data set in that Google Colab file, we get to see multiple columns. So on
Correct.
which column specifically?
So carefully look at this code and let me know. Think 1 minute.
Okay, sir, got it.
Very good. Next. All right. Let's go to the next part of the story. There's a person who is standing on this side of the river. Okay. He has to cross the river. He has to go from point A to point B. And this guy, he doesn't know how to swim. If he gets into the river, he may get drowned. He's very afraid. There's another guy who's standing by the side of the river. So he asks him, what is the depth of the river? So the response is, on an average, it's 4 feet. And this person is very smart. He just attended this class. He asks him, tell me the mean depth as well as median depth. And this person, yeah, mean depth 4 feet. Median is also 4 feet. Don't be over smart. Both are 4 feet. And this person is around 6 feet tall. He thinks that I'm 6 feet and the average depth is 4 feet. He starts crossing. Do you think always he's going to reach point B? For sure, without fail? Is there a
Yes, sir.
chance for drowning? What do you think?
There is a
No,
chance.
sir, no chance.
Absolutely no chance of drowning. Every time from A to B, he will reach for sure.
Yes, sir.
100% wrong.
There is a chance of
There is
Never
a
try
chance of
that.
drowning, sir. There is a chance of
Never try that. Okay. Because average depth 4 feet, does it mean everywhere precisely exactly 4 feet it will be there?
No.
No, sir.
Sometimes the depth will be less than 1 feet, less than 2 feet. Maybe sometimes the depth is 4 feet only. Sometimes the depth is 5 feet, 6 feet, 8 feet, 10 feet, 11, 12 feet. Is there a possibility? If average is 4, does it mean every point is going to be 4?
No, sir.
Is there a chance that there are some points where the depth is much more than 4 feet?
Yes.
Is there a chance of drowning? Tell me now.
Yes.
Yes, sir.
Average
There is a chance
depth
of
4
drowning.
feet doesn't necessarily mean everywhere it will be 4 feet. Isn't it? Let me give you a different example. Let's say there were two companies, company A, company B. For both the companies, if I see their profits, that is known as PAT, profit after tax. Profit for company A is $15 million in last 3 years. Profit for company B is $15 million for last 3 years. If I am going to invest in one of these two companies, I want to invest in a less risky company. Which company I would select? I can select any one of them because both of them have $15 million each. But if I give you the actual data, this is company A with $15 million profit average, company B with $15 million profit average. If I now ask you, suggest me a company that is less risky.
Company B.
Company B.
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 Everybody unanimously you are saying company B, company B, company B. What's the reason? Company A, company B, both of them have $15 million as the average. However, for company A, sometimes the profits are going way above $15 million. But are you happy?
Mm,
No.
No.
Sometimes the profits are going way below $15 million. Sometimes we are incurring losses as well. Whereas for company B, consistently the profits are around $15 million, where for company A, it is going far above 15 million, far below 15 million. There is a lot of dispersion in company A compared to company B. Company B has less spread in the data, where company A has more spread in the data. Their average is same. Can I always take the decision based on the average value? Are we taking the decision based on the average value here? No. We looked at the dispersion in the data. I think all of you have observed dispersion in the data, yes or no? You thought that there is less dispersion, there is a lot of consistency in company B. That's why you picked it, yes or no?
Yes, sir.
Yes, sir.
Somehow we have to quantify that dispersion. Earlier, you have roughly picked it, B. Can you quantify the dispersion and give a number to A, there is higher dispersion. Give a number to B, there is lower dispersion. You can quantify the dispersion using a measure called variance. Variance is the measure of dispersion. What it does, it tries to quantify how dispersed company A is, how dispersed the company B is. It will give a number to company A, it will give a number to company B. Let us see how variance is calculated. A very simple formula. Company A values, company B values. Let us denote them by xi, yi. First, calculate the average profit for company A, average for company B. Both are one and the same. Now what you do is value minus average, value minus mean, value minus mean. That will be xi minus x bar. That will be yi minus y bar. 23 minus 15. 44 minus 15. 0 minus 15. 25 minus 15. So these are all the value minus mean values. Now, if this deviation is a higher value, what does that mean? If these deviations are larger values, it means there is higher dispersion or lower dispersion.
Higher dispersion.
House.
Higher
If these
dispersion.
deviations are larger values, then there is higher dispersion. If there is higher dispersion, just to quantify it, can I directly take the summation of all these values?
No.
Is it a good idea if I take simply the summation of all these values? To get an idea on the dispersion, can I take the summation? Why I cannot take the summation? Somebody tell me.
There is negative value in between.
There are
Because of
some
positive
negative
and
values, there are some positives, there are some negative values in between. That's right. Since there are negative values, there may be some kind of cancellation effect that will happen, isn't it? So direct summation I should not do. Yes, this gives me an idea on the dispersion, but directly I cannot do the summation of it. What I have to do is I take the value minus mean whole square. I'll square it up. 28 square, 29 square, minus 15 square, 10 square, 5 square, 20 square, minus 23 square. Whether it is positive or negative, it will be a positive value if you square it. The same calculation you do here as well. yi minus y bar whole square. Then take the mean of all such squared deviations. How do you take the mean? Sum divided by count. That is the variance. Variance for company A is 352. Variance for company B is 4.9. Variance for company A is 352. Variance for company B is 4.9. Imagine I gave you this table. Company A average is this much, variance is this much. Company B average is this much, variance is this much. What do you think? If I ask you for a company that is less risky, do you really need the full data now, or is this table sufficient for you?
This much is sufficient.
This much is sufficient. Can you suggest me which one is a less risky company? The company that has?
Less variance.
Variance.
Yes or no? What if I'm a trader? I want to invest today. Within a week, I want to sell off for a small profit. I want to invest today. Within 2 weeks, I want to sell off. Even if it is going to losses, I want to exit quickly, enter quickly. I want multiple entry points. I want multiple exit points. I'm a trader. I'm not a long-term investor. In that case, which company do you suggest me?
A.
Company.
Company A has multiple entry and exit opportunities. Yes or no? So the
Yes, sir.
company that has higher variance. Is it fair to say whether high variance is good or whether low variance is good? That totally depends on the business problem. Isn't that true?
Yes, sir.
Whether you're looking for high variance or whether you're looking for low variance, you should decide that based on the business problem that you're solving. If you're looking for less risky companies, then you're looking for less variance. You're looking for consistency. If you're looking for high risky companies, if you're a trader, then you are looking for high variance companies. So we cannot always say that less variance is a good idea. It depends on the problem statement that we are handling. Do you agree or not? We cannot always say that less variance, just choose this. No, not necessarily. Sometimes you want versatility. Then you go for high variance. So if you see these formulas, in fact, in this course, whenever you see any formula, you don't need to memorize it. Never memorize any formula. That's not required. But you must understand it, how it comes. Is it easy to understand? Look at this now. Xi is the value. X bar. What is X bar?
It's the mean.
Mean. Xi minus X bar, which is a deviation. And you know why we have squared it up? Because there are some negatives, there are some positives. Then take the sum divided by count. This is variance. Again, you can always refer to this formula later on, but you don't need to memorize it. Okay. Not only this formula, in future, any of the formulas that come in this course, you never need to memorize any of the formulas. Okay. Now, the only counterintuitive point in this whole discussion here is if the value is in dollars, variance will be in dollar square. If the value is in meters, variance will be in square meters. Yes or no? Have you observed it?
Yes, sir.
If the value is in cents, it will be cent square. Sometimes it sounds counterintuitive. It looks like unnecessarily we are giving a larger value than what it is. That is why there's another connected measure to variance, which is known as standard deviation. In simple words, standard deviation is nothing but square root of variance. Standard deviation is nothing but square root of variance. Do not look at standard deviation and variance as two different measures. Aren't they telling you the same story? Yes or no?
Yes.
Standard deviation is simply square root of variance. Are you with me, everyone?
Yes, sir.
Let us suppose instead of
Yes, sir.
looking at variance. If I calculate standard deviation, do you think our results will change? If I ask for less risky company, will it be A now? Or it will be same?
Same.
Whether you're using variance or whether you're using standard deviation, the results will be same. The conclusions will be same. Do you agree with that? Because standard
Yeah.
deviation is simply square root of variance. So you can use either standard deviation or variance when you're doing the analysis. So here, these are basic descriptive statistics. We don't really build big strategies with this. We try to understand how the data is. We try to get some basic measures. So usually it's the standard deviation that is used to make the final decision, because the units of standard deviations are also in line with the original data. Let us do a small exercise. I have a data set called online retail sales data. In that data set, I have two countries. One is Germany, the other one is France. There are other countries as well, but my interest lies with Germany and France. What I want to know is, where are we selling most versatile products? That means where the unit price is varying a lot. We have a lot of unit price values. We are selling so many products. Too many products. Is it Germany that we are selling too many products, or is it France that we are selling too many products? Where are we selling them? How do you get to know that? You look at the unit price variance in Germany. You look at the unit price variance in France. What am I looking for? Am I looking for consistency or am I looking for versatility?
Consistency.
Think about it.
Versatile.
Too many products. I want too many products, isn't it? I'm looking for versatility. That means I have to calculate the variance and I'll go with that one where there is higher variance. So tell me, what is the variance of unit price in Germany? 385 point something. What is the unit price of variance or unit price variance in France? 7910 point something. Check these values. Are these correct? All of you check these numbers. Yes, it is correct. Yeah, makes sense. So where is there is a lot of versatility? Where are we selling too many different products? Is it Germany or France? Where are we selling them? Wherever there is higher variance, that indicates that is nothing but France. Mean, median, variance, standard deviation. We don't really calculate them to build the strategies. We calculate them to get an idea on the data. We use them as descriptive statistics. We use them for describing the data. Later on in the advanced machine learning algorithms, these formulas go as sub-formulas inside the larger, bigger formulas. So later on, the machine learning and other algorithms are built on top of these fundamental concepts. Yeah. So one of the question is how to work on Colab. Please help. So have you worked on Jupyter Notebook earlier? Shankar? You have worked on Jupyter Notebook, right? So the way we work on Jupyter Notebook, exactly the same. 0% difference. How do you execute a command in Jupyter Notebook? How do you execute a command in Jupyter Notebook? Control Enter. You just say Control Enter here. So even the shortcut is given here. Shift Enter is also fine. Control Enter is also fine. Are you comfortable with this, Shankar? You are unable to open the Colab file. I am sharing the link here. Have you clicked on the link that is shared with you? Click on the link that is shared with you. Yeah. Can you please confirm whether you can open it now? Got it. All right. Perfect. Let's take a pause here and take the questions. Any questions? Anybody? Let's go to the next part of the story. Are you ready? Okay. Somebody attempted an exam. He got 80 marks out of 100 marks. The exam was for 100 marks. He got 80 marks. What do you think? Is he doing a good job or not? Is he doing a good job or not?
Good job.
Let's say around 10,000 other students also attempted the same exam, and this guy got around 80 out of 100 marks. It looks like, on the face of it, it looks like he's doing a good job. But there are two scenarios. Scenario one, suppose that he got 80 marks out of 100 marks, but below him, there are 9,000 students. Above him, there are only 1,000 students. So with 80 marks, he outsmarted 90% of the students. With 80 marks, there are only 10% of the students who got better than 80 marks. So even though he got 80 marks, which percentile he is standing at? Since below him, there are 90% of the people, we can say he is safely standing at which percentile?
90%.
90 percentile.
90 percentile. So somebody gets 90 percentile. Is he doing a good job?
Yes, sir.
Of course, he's doing a good job.
Yes, sir.
That is the scenario that we are imagining. But there can be another scenario, scenario two. What if it's an online exam? Have you given an exam in DV? Of course you have already, right? You know how it works. Yes. So in some other scenario, he got 80 marks, but below him, there are only 500 students. Above him, there are 9,500 students. Even though he got 80 marks, below him, there are only 5% of the students. Above him, there are 95% of the students. With 80 marks, with the same 80 marks, below him, there are only 5% of the students. So he's standing at which percentile? Now,
5
Five.
percentile.
with the same 80 marks, he's standing at 5 percentile. The marks are same, 80, 80. But in scenario 1, he's standing at 90 percentile. In scenario 2, he's standing at 5 percentile. Sometimes looking at the standalone number, you will not get the right picture. You may have to compare that number with the rest of the data. You can do that by using percentiles. Shankar, please go on mute. Let me mute all. Yep. Can you hear me clearly, all of you? Is there any issue?
Yes, sir.
We can hear you.
Okay, fine. So even though the number is same, we must compare where exactly it stands. That can be done by using percentiles. Usually percentiles are used in exams and all that. We can use percentiles for doing analysis also. So let me explain you how percentiles are calculated. How can we use percentiles for doing our analysis? Let us do that. Percentiles are firstly calculated for numerical values like income, examination marks, or expenses, or number of loans, etc. For example, if you want to calculate the percentile for income. So if you want to calculate the percentile for income, let's say I want to know the 10th percentile of income. What is the 10th percentile value of income? If you want to calculate the 10th percentile value, this is the process. You first arrange income in the descending order. Income. This is the max value of income. This is the minimum value of income. You arrange income in the descending order, maximum to minimum. Let us suppose minimum value of income is $1,500. Maximum value of income is $100,000. $1 lakh is the max value, minimum is $1,500. Now, what is the 10th percentile value? What is that particular income value? What is that particular income value where below it is, let's say if this is 10th percentile, if I'm saying this is 10th percentile value of income, let's say that happens to be $2,800. If that happens to be 10th percentile, what is the speciality of $2,800? Tell me. What exactly that $2,800? Precisely below $2,800, how many percent of the people will be there? What percent of the people? What percent of the
10%.
population will be there? 10% will be
10%.
here. About $2,800, what percent of the population will be there?
90%.
90%. Are you understanding? When I said 10th percentile value is $2,800, what is the speciality of that number? Below that number, 10% of the data. Above that number, 90% of the data. Similarly, if I ask for 20 percentile value, what is that particular number where below it is? I have to look for that number. I have to look for that income value where below that income, how much of the data should be there?
20%.
20% of the data should be there below it. Let's say that happens to be $4,350. What is the speciality of $4,350? Below $4,350, what percent of the population is lying?
20%.
20%.
20%.
Above $4,350, 80% is lying. Like that, you can calculate 30 percentile, 40 percentile, 50 percentile, like that. You can calculate and so on, 70, 80 percentile, even 90 percentile. What is 90 percentile? Tell me. Let's say 90 percentile is $75,000. That's what I'm saying. 90 percentile is $75,000. What is the speciality of $75,000? Above $75,000, what percent of the people are there?
10%.
10%.
Here there is 10%, below it is 90%. 10%, 20%, 30%, 40%. What is 0 percentile value? What will be that income value which is constitute to 0 percentile? That means below that income, 0, nobody is there, and everybody is above that income. Think about it.
The least value.
1%.
Minimum.
Minimum value, the least value, does that make sense? Can I write $1,500 here? Is it qualified as 0 percentile? Think about it. What percent of the population is there below $1,500? What percent? 0%.
No population.
Yeah. So can we say minimum value is nothing but 0 percentile? Do you agree with that statement?
Yes.
For any data set, minimum value is 0%. Can I say 0 percentile is always 0 for every data set?
Yes.
Is 0 percentile
No.
always 0 for
No,
every
no.
data
No,
set that
sir.
we
No,
come
sir.
across?
No, sir.
No, sir.
What is the 0 percentile value here in this data set?
1,500.
Will it be
1500.
always $1,500 for everybody?
No, sir.
No. Make sense or not? Similarly,
Yes.
what is 100 percentile? That means that
Sorry?
particular number where below it is 100% of the data, above it is nothing.
Maximum.
Maximum, makes sense. Maximum value, which is 100,000. Here in this case, $100,000, $1 lakh. 0 percentile minimum value, 100 percentile maximum value. Is this particularly clear? These 2 points? Are you convinced with the logic? 0
Yes, sir.
percentile, 100 percentile, minimum and maximum.
Sure.
There is one more percentile that we already discussed with a different name earlier. Out of the percentiles that I have mentioned here, there's one more percentile that we have already discussed with a different name. Can you think about it? Which percentile is that?
50%.
50 percentile. What is 50 percentile? What was the
Median.
different name that we discussed
Median.
earlier?
Median.
Median.
Is it
Median.
median or is it mean? Think about it carefully and let me know. Or is it
Median.
both mean and median, or either median or mean? What is the right answer? Always the right answer is median.
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 Is it true that median is right at the center? 50% is below it, 50% is above it. Can I call 50 percentile as median?
Yes, sir.
0 percentile is minimum value. 50 percentile is the median value. 100 percentile is the maximum value. Yes or no? Yeah. Let us get a better understanding of these percentiles by taking one live example. Okay. Then we'll be able to find out what exactly these percentiles are trying to tell us. How do you calculate percentiles? Like earlier one was the procedure, but directly we can use a function in Python called quantile. Look at the spelling here. It's coming as in quantity, quantile. You write data frame name dot column name dot quantile. 0 means 0 percentile. 0.1 means 10 percentile, 20 percentile, 30 percentile. So if you ask for 0 percentile, Python will calculate and give you the minimum value. 10 percentile, Python will automatically arrange the data from max value to min value of capital gain and find out that point where 10 percentile is lying. 40, 50, 60, 70. Are these the only percentiles that I can fetch? Or can I, let's say, if I want to fetch 75 percentile, what should I write here?
0.75.
Simply write down 0.75. You will get 0.75. Isn't it? 75 percentile also you'll get. It's not necessary that you have to write only these numbers. You can ask for any percentile between 0 to 100. 0 is 0 percentile. 1 means 100 percentile. All right. So let's execute this code. I'll tell you how to interpret that output and see how do we analyze a variable by using percentiles. All of you go ahead, execute this output. Then I'll tell you how to analyze this output. Are you ready with the output, all of you?
Yes, sir.
All right. Let's discuss. All right. Are you ready for the output discussion? Let's go ahead. So you have two columns. One is the percentile column, whatever you have asked for. The other one is variable value. Here the variable name is capital gain. Capital gain value. So 0 percentile. So what is a 0 percentile, which is a minimum value of capital gain? What is the 0 percentile value that you have got?
0.
0.
0. So if 0 percentile is 0, what will be your inference? What will be your interpretation out of this?
Minimum value is
Minimum value of capital gain is 0. Are there any negative values in the capital gain?
No.
No, sir.
Are you absolutely sure about it?
Yes.
Yes, sir.
I think there was
Because that is
minus 30 or minus 18 lying somewhere. Do you think so?
No, sir.
If there would have been minus 30 lying, if that is the minimum value, what would have been 0 percentile? Minus 30 itself. So can we 100%, can we give guarantee that minimum value is 0?
Yes, sir.
Of course, we can give
Yes.
0 percentile is 0. Are you absolutely clear on this interpretation, all of you? Yeah? Make sense? Let's go to 10th percentile value. What is the 10th percentile value? That is also 0. 10th percentile is also 0. Can I say 10% of the data in capital gain is 0 only? Is that our first interpretation? Tell me.
Yes, sir.
10% of data in capital gain consists of zeros only. Tell me, is that a right statement or not?
Yes, sir.
Yes, sir.
Yes,
It's
sir.
a right statement.
Yeah? Does that make sense? Because 0 percentile is also 0, minimum value is also 0, 10th percentile is also 0. That means these all must be zeros, 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 zeros. 10% of the data is 0. What about remaining 90%? Can I say remaining 90% is definitely greater than 0? Or we are not sure? Can I give guarantee that this whole data is greater than 0?
Yes, sir.
Definitely,
sir.
always, in all the cases, definitely it will be greater than 0?
No,
For
sir.
sure?
No, sir.
Not sure. Do you agree? Because we can only talk, we have seen only until 10 percentile. We can only talk about the data until 10 percentile. Can we talk about the data that we haven't seen? Can we give guarantee on that side?
No.
You cannot give because we haven't seen that data. We have observed only data until 0 to 10 percentile. That only we can write with confidence. The remaining 90% greater than 0, I'm not sure. What about 20 percentile value?
It is also 0.
That is also 0. 20 percentile is also 0. That means, what will be your interpretation? Participate everyone. What will be your interpretation? By looking at 20 percentile value, which is 0. You have seen minimum 0, 10 percentile 0, 20 percentile 0. What will you write here? 20% of capital gain is
0.
0. How about remaining 80% of the data?
We can't say.
Can I say it will be always greater than 0 for sure or not sure?
Not
We
sure.
cannot
We are
comment
not
on
sure, sir.
We
Not
are
sure.
not sure, sir. Like that, you have 30 percentile, 40 percentile, 50, 60, 70, 80 percentile value. What's the 80 percentile value? What's the 80
Zero.
percentile value? Oh, that is also
Zero only.
No, sir.
0 only. Tell me, what is your first point of interpretation if 80 percentile is also 0? 0 percentile, 10, 20, 30, 40, 50, everything is 0 until here. So what will you say? What will be your first point? 80% of capital gain is 0. Is that a right statement or not?
Yes, sir. It's a
80%
right statement.
of capital gain is 0. How about remaining 20%? That must be greater than 0. Are you absolutely sure? If 80% is 0, remaining 20% must be greater than 0.
No, sir.
Not sure,
No,
sir.
sir.
Have you seen that data?
No, sir.
How much of the data we have observed until now?
80%.
80%. Remaining 20%, we are not sure. I'm sorry. We can talk about 80% of the data. All of that is zeros. Maybe remaining 20%, maybe greater than 0. I'm not sure. What is 90 percentile value? 90 percentile value is also 0. Damn it. What is your first statement?
90% of capital gain is 0.
90% of capital gain is 0 for sure. That we are sure because I have seen 90% of the data. I'm pretty sure. How about remaining 10%? Will it be for sure greater than 0 everywhere?
No, sir.
Not sure. Not sure.
Greater than 0. Are you sure? Not sure. Have you seen that data? For you to be very sure, you have to observe, you have to see, you have to analyze. Have we done that?
No.
Not yet. I'm not sure. I have to see. What is the 100 percentile value?
5 times 9, sir.
99999. Is it right to conclude that, you know what, I have analyzed the data, I'm damn sure that 90% of this data here, 90% of the data is 0, 10% of the data is definitely greater than 0. Can I conclude it that way?
Yes.
No,
Yes, sir.
For
Yes.
sure,
Yes.
100%,
No, sir.
guaranteed, always, without doubt. Is that a right conclusion? Perfect conclusion? Think about a scenario where 99% of the data is 0. Only 1% is greater than 0. Think about a situation where 99% of the data is 0, only 1% is greater than 0. In that case also 90 percentile will be 0.
Yes, sir.
Yes.
When 99% of the data is 0, will 90 percentile be 0?
Yes.
Yes.
sir.
So
Yes,
is
sir.
it fair to say
sir.
that you have seen 90 percentile, you have seen the maximum value? Can you always conclude that 90% will be 0, remaining whole 10% will be greater than 0?
No, sir.
Is
No,
it
sir.
smart
No.
to conclude like that? Can I take all the 10%? Have you really seen that last 10% of the data?
No, sir.
Have we really got the clarity on 10%?
Not
We
really.
have got clarity on 90% of the data. What's there to get the clarity? It's all 0, 0, 0, 0. 90% of the data, we are clear. But are we clear on the last 10% of the data as of now?
No.
No,
No.
sir.
Do you think we have to drill down to get a better understanding of it?
Yes.
Do you think we have to look at 91 percentile, 92 percentile, 93 percentile, 99 percentile, 100 percentile to get the better understanding of the data so that we drill down and understand exactly what percent is 0, what percent is non-zero?
Yes, sir.
Do you agree with that? Let us see, how do you do the drill down? How do I get the 91 percentile, 92 percentile, 93 percentile? Can you tell me the code for it? 0.9
The same
is
code
90
we will
percentile.
replace.
0.91,
9.
0.92, 0.93. Does it make sense or not? Tell me.
Yes.
Yes, sir.
Are you with me, everyone? Following the syntax?
Yes,
Yes.
sir.
Perfect. What I want you to do is listen to this carefully. I
Yes,
want you to
sir.
drill down from 90 percentile to 100 percentile and answer this simple question. What percent of capital gain is actually 0? What percent? Is it 90? Is it 95? Is it 99? What percent of capital gain is greater than 0? So give me a 2-word answer in the chat window. Please go on mute and analyze the data. Finally, try to answer these 2 questions precisely. What percent of the data is 0 in capital gain? What percent is greater than 0? Your answer must contain exactly 2 words. What percent is 0? What percent is greater than 0? Everybody must answer in your own way. Maybe the first answer may not be always the right answer. You give me your answer, then I'll write down finally my answer.
$92 percentile is greater than 0.
92% of the data is greater than 0. I
Sorry,
don't
sir,
believe that.
no, sir.
No, बोल दिया, अभी तो बोला तो गया. So 91% of the data is 0.
9%. Yes.
91% of the data is 0. That is the
0,
answer
yeah.
to the first question. Yes or no?
Yeah. Yes.
Yeah. Any question about this? This one everybody will be right. And how much of the data is remaining? If 91% is 0, remaining 9%.
9%.
Yeah. Even if you drill down further, maybe some of you might have put an effort to make it like 91.6, something like 8.4. That also you can do, but at this level of granularity, you can stop. Already we are making the data into 100 pieces. 91% of the data is 0, 9% of the data is greater than 0. Have you understood this analysis, all of you?
Yes, sir. Yes, sir.
91% of the data in capital gain is 0. Tell me honestly, when you were calculating the mean value, when you were calculating the median value, have you really imagined that capital gain has 91% of the data zeros?
No, sir.
No, sir.
Tell me
No,
honestly,
sir.
when we were calculating mean, we got mean value of capital gain as 1077. Have we really
No.
imagined that the data has 91% of the data was zeros?
No, sir.
Isn't it? So what did we do here? We looked at the minimum value of capital gain, which is 0. We kept on analyzing until maximum value of capital gain. We looked at every possible value the capital gain takes. Where is the whole concentration of this variable? This is known as distribution of a variable. Distribution of capital gain. From its minimum value to its maximum value, we see what all values a particular variable takes. That is known as distribution. Where is the whole concentration of that variable? What all values, which range it takes? That is known as distribution of a variable. Capital gain ranging from 0 to 99999. Do you think every variable will range only in these values? Do you think age will also have the same distribution in this data set?
No.
Do you think age will also have 80%, 90% zeros in it? Or it will have a different distribution altogether?
Different
Different
They have a
distribution.
different distribution. You can get an idea on the distribution of a variable by looking at all these percentiles. You can completely strip a variable from its minimum value to maximum value. You can understand completely what all values it takes. Does that make sense or not? All of you?
Yes,
Yes, sir.
Now we go to our client, our business partner. We tell him that 91% of the capital gain value is 0. Only 9% is greater than 0. That's what we found out. We found out by doing the distribution analysis. When we looked at the percentiles, we found that 91% of the data in capital gain is 0. Then the client will tell you from the business point of view. From the business point of view, what are the From the business point of view, what are the implications? So the client, imagine I'm your client, I'm telling you, you know what? Capital gain has to be always 0. Capital gain has to be always 0. Any value which is greater than 0, any value which is less than 0 is considered as an outlier. Capital gain has to be absolutely 0. If that is the case, how much of the data is clean here? How much of the data is having outliers?
91% is
91% of the
clean.
data is clean.
9%
9% of
outlier.
the data has
Out.
outliers. So when you're deciding outliers, outliers must not be decided just by looking statistical analysis like this. Outliers are decided based on 2 factors. Factor number 1 is statistical analysis. Using statistical analysis, using percentile distribution, you will decide. Plus, you always keep in business context. You have to also look at the business context. For example, if I give you one variable age value is, let's say, 85. Same variable, same value. Let me give you scenario 1. In scenario 1, you are dealing a loans portfolio, personal loans portfolio. Age of 85. A customer has age 85. in personal loans portfolio? Is it normal? Is it usual? Or is it considered as an outlier? Age of 85.
Outliers.
Yes, sir.
Outlier for sure. In scenario 2, same age, same value. You're dealing with savings bank account portfolio. A person having savings bank account at age 85, is it odd? Is it an outlier? Or is it normal data? Is it acceptable?
Acceptable, sir.
Is this an outlier here in this case?
No,
This
sir.
is not outlier. Do you agree? It's not just the statistical analysis we have to follow. We have to look at the business context plus the statistical analysis. Does that make sense?
Yes.
Yeah. Always we must understand the business context. Without understanding the business context, never ever start the analysis. Never ever even download the data without knowing what is the business context. Do you agree with that point?
Yes, sir.
Yeah. Because all of us using data science or data analytics, we are solving a business problem. If we don't even have an idea on the business problem, what we are solving, we will not be able to give the right analysis. Okay. Let us recap this whole outlier detection by using another example. This one is a real one. This is a credit risk data. This credit risk data is used in calculating credit score. Do you know what is credit score? Which bureau provides credit score in India?
Sibyl.
CIBIL is the one, isn't it? CIBIL score. So basically, what is a credit score? Before giving a loan or before giving a credit card, banks or financial institutes, they want to know whether you're a risky customer or whether you're a non-risky customer. If you're a non-risky customer, then they'll give you a loan. If you are a risky customer, they would not give you a loan, or they will lower the loan amount, or they will increase the interest rate because you are risky. So that is the credit score. Here, we are taking a data set that will be used for building the credit risk scorecard. But are we building the credit risk scorecard right now here in this exercise? What are we doing here? We are looking at the exploratory data analysis. We are exploring the data. We're trying to find the outliers right now. Maybe this one we will do it later, building the risk scorecard. As of now, what are we trying to do here? We are trying to do the data exploration. Find out whether there are any issues or not in this data. One of the variable used in this data set is monthly utilization. Monthly utilization percent. Monthly utilization percent. Imagine you have two customers, customer A, customer B. Customer A has a credit limit of 1 lakh. Customer B also has a credit limit of 1 lakh. Customer A, on an average, he uses 95,000 on an average. Sometimes he swipes online, offline, everywhere. He uses 95,000. So what is the monthly utilization percent for customer A?
95%.
95%.
Customer B utilizes on an average 12,000. Utilization percent is 12%. So this is 0.95 numerically. This is 0.12. Tell me, if a financial institute looks at these two customers, who is considered as risky? Which customer is risky?
A.
Whenever you think of risk, you look at the adverse scenarios. Let's say one fine day, both customer A, customer B absconded. Both of them are not available. Both of them. So what will be the risk? What will be the loss made by customer A roughly?
95,000.
What will be the
95,000.
loss that you will incur from B?
12,000 only.
So where is higher risk?
A.
A.
Customer A.
Now it is easier, isn't it? Always you are at higher risk with respect to customer A. Now monthly utilization percentage, is it a good indicator of credit risk or not?
Yes, sir.
Do you think companies should use it, monthly utilization percentage?
Yes, sir.
Yes.
Monthly utilization percentage. If somebody has higher monthly utilization percentage, there is a higher risk. That person is credit hungry. We have to be careful. So this is one of the variable that is used in this data. Now we want to explore that variable, find out if there are any outliers in that variable or not. Are there any outliers? Let us see. Monthly utilization percentage. What's the minimum value that it can take from the business point of view? Tell me, what's the minimum value? If somebody is not at all using the card, what will be the monthly utilization percentage minimum value?
0.
0%, isn't it? Which is 0. Yes or no? Ayana.
Yes, sir. It's 0%.
Yes, sir.
What is the maximum value that it can take?
100%.
100%.
What is the maximum value? 100%? Yes or no? If somebody is using 1 lakh out of 1 lakh, that means 100% utilization. If 1 lakh is the credit limit, can you swipe for 1 lakh 50,000? Can I use 150% of
sir.
my credit limit?
No.
No.
Will the system
No.
allow?
No.
If 1 lakh is the credit limit, can you buy a product which is priced at 1,50,000? No, the maximum value is 1 only. Minimum value is 0, maximum value is 1. Do you think in the data set that you got, always you will have the numbers between 0 and 1 only, nothing will be beyond that? If you get the data between 0 and 1, that is clean. Sometimes you may get the data which is less than 0, which is outlier, erroneous. Greater than 1, which is also outlier.
Outlier.
Even if it is 1.001, is it possible? Think about it.
No.
Is it possible to have anything which is greater than 100% credit limit?
No, sir.
Not possible. Even 1.001 is also an outlier. So what I want you to do right now is import this data set, go to this monthly utilization variable, analyze this whole data, and don't paste the output in the chat window. What you have to do is, what percent of the data is clean? That means it is between 0 to 1. What percent? What percent of the data has outliers, which is like less than 0, greater than 1? So give me a 2-word answer in the chat window. Okay. Maybe this is 90, this is 10, this is 95, this is 5, 92, 8. So analyze by yourself. And what I want you to do is calculate and let me know what percent of the data is clean, what percent of the data is outliers. All of you must do it. Everybody must put your own answer. Then I'll discuss. Okay, go ahead, spend a good amount of time on this and then answer these 2 questions. Give me your own answer.
Sir, I didn't get the question. Could you please come up again?
What percent of the data is clean? What percentage? What percent of the data is outliers? There are 2 numbers that I'm looking for in your output, in your chat. The clean percentage, outlier percentage. Let me also do it. Let's get loans data. First, 0 percentile is 0. That means minimum value is 0. Are there any negative values? Is there anything less than 0?
No, sir.
Nothing. 10th percentile is fine, 20 is fine, 30 is fine, 40, 50, 60, until 90 percentile is fine. 100 percentile is 50708. Is it possible?
No, sir.
1 lakh is the credit limit. Somebody is swiped for 507 crores. 1 lakh is the credit limit and somebody has swiped for 507 crores. Do you think this is just a general outlier? We can let this data as it is, or do you think these kind of outliers turn the analysis upside down? Your maximum value that is possible is 1, but here it is 50708, 50,000. Even though the outliers is smaller amount, sometimes they will have a huge impact because of their magnitude. Now, can I simply conclude 90% of the data is clean, 90% is clean, 10% is outliers? Simple conclusion. Makes sense? Makes sense?
Yes,
No,
sir.
sir.
We cannot say this whole 10% is outliers. We cannot say like that. 90% is clean. That's partially right. But the whole 10% is outliers. Nope. We have to do the drill down. Have you done that, all of you? 0.9,
Yes, sir. We have done that.
0.91, 0.92, 0.93, 94, 95, 96, 97, 98, 99, 100%. 90 percentile is fine. 91 percentile is 100. 92%. Can somebody have 100% credit limit utilized? Monthly utilization percentage, can it be 100%? Theoretically, is it possible?
Yes, sir.
Yeah. You have 1 lakh limit. Can you use 1 lakh? Yes. So these are all acceptable until 97. How about 98 percentile? 1 lakh is the credit limit. Somebody swiped for 1 lakh 6,000. Is it possible? Will the system allow? Can the credit limit be
No.
more than 1 lakh? Can the
No,
monthly
sir.
utilization percentage be more than 100%? No. So is it fair to say 97% of the data is clean? 3% of the data is outliers. Are you with me, everyone? 3% of the data is outliers. The reason is you cannot have credit limit even more than 1, even if it is a smaller value, but in the business context wise, maybe if you just look at the number, what it looks like, 1 and then 1.006. Does it look like an outlier when you just look at the number in standalone? But if you mix the business context in that, this is 100% utilization. This is beyond 100% utilization, which is impossible. I would say 97% is clean, 3% is outlier. Maybe you can take it to a level 97.5% is clean, around 2.5% is outlier, but that is not required here. 97 and 3 is good enough. Are you with me, everyone? Please go ahead if you have any question, anybody.
Yes, sir.
Yeah, Pankaj, go ahead. Yeah, go ahead. Whomsoever has a question. Have you clearly
No
understood?
questions, sir.
No questions? Okay, perfect. Understood, everyone? Any data set that is given to you, will you be able to look at the standard percentiles like this?
Yes, sir. We can do
If
that.
you have
Yes, sir.
found any issues, can you do a drill down like this?
Yeah.
By looking at the business context, will you be able to identify the outliers on your own in future?
Yes, sir.
If the same question is asked in the interview, will you confidently say that, yes, I can find out outliers, whatever is the data? That
Yes.
is it. That is one of the skill. Do you think there will be issues in the data? Yes, there will be. As a data scientist, we have to do outlier detection. Later on, I'll tell you how to clean that data. But as of now, outlier detection, is it clear? Yeah.
Yes, sir. Sir, I'm not. Can I?
Please go ahead.
Sir, for one column we can find outliers like this, sir. But what about the entire data set, sir?
One by one column. It's a tedious process.
Yes,
Data
sir.
exploration is a very tedious process. It takes a hell lot of time. We cannot have shortcuts in it. The reason is for monthly utilization, the limits are 0 to 1. In the same portfolio, can I take the limits for age as well to 0 to 1? No. Maybe for age, the limits are maybe from 18 to 62. Those are the limits. Beyond them, they will be called as outliers. Yes or no? For income, there will be other limits. So outlier detection process is a tedious and time-taking process. We have to go through each and every variable. Right now, we found this as issues. Next year, if you are getting the data again, would you get exactly the same issue like this? Would you get exactly 97% clean, exactly 3% issues, or there will be different issue?
Difference.
There will be different issues, sir.
Can I always simply take first 97% of the data, it will be clean, last 3% there will be issues? No, there will be different issue. Yes, it is time consuming process. One by one variable, we have to do it in a data set. Fine. All right, everyone. Okay. There is another connected small concept called quartiles. Here we have seen percentiles. There are some special percentiles. They are known as quartiles. 25th percentile is known as first quartile. 50th percentile, which is also known as median, second quartile. 75 percentile, which is known as third quartile. If somebody want to overly simplify, if you ask what is your percentile, somebody says, I fall in third quartile. What is he trying to say? Or this number falls in third quartile. So they're trying to tell this particular number is in which range? From
50 to 75.
75.
third quartile, 75 percentile to 100
100
percentile. 50 to 75 percentile is what?
median second.
Second quartile. And then what is first quartile? 25 to 50. So basically the first quartile is below first quartile. Your quartile 1 is P25. So below first quartile is 0 to 25. Second quartile is at 50. Third quartile is this one. What is the use of these quartiles? There is another connected concept to this, which is known as box plots. Now, one of the questions that was asked earlier was, what if there are too many variables? What if there are too many variables in a data set? Let's say I have 200 variables in a data set. Do I really need to do this for every variable? Is it going to be a time-consuming process? Yes, it is. Is there a shortcut for it? Can I do it quickly? There is not exactly precisely a shortcut, but somehow you can use box plots for quickly finding out whether there are any outliers or not. Here, you have to go through too many numbers to find out outliers. Here, just by visualization, quickly looking at, you can visualize the data in the form of box plot and very easily tell whether there are any outliers present or not. Let us first see how box plots are drawn. Let us imagine there are two variables, x and y, and these are their details. For x, 0 percentile, 25 percentile, which is quartile 1, 50 percentile, quartile 2, and then 75 percentile, quartile 3, 100 percentile, maximum value. And corresponding values of y are 0 percentile, 25 percentile, 50 percentile, 75 percentile, and 100 percentile. So 0 percentile is 0 for x, 25 percentile is somewhere around 12, 50 percentile is 26, 75 percentile is around 39, 100 percentile is around 54. That is x. And the y is somewhere around 0, 12, around 26, 39, and let's say 5 million or something. Now let us draw the box plot for x. These are two distinct variables. X has no connection to y. Let us draw the box plot for x. This is how it goes. Look at this, all of you. What is the 0 percentile value? First you draw that. This is the 0 percentile value. What is the 25%? Let me put the graph here. So this is 10, this is 20, this is 30, 40, 50, 60. Now, what is the 25 percentile value for X? That is 12. Where does that come? 12. 25 percentile, which is also known as quartile 1. Are you with me, everyone?
Yes, sir.
Where
Yes,
is the
sir.
50 percentile value?
15 to
26.
60.
Somewhere here. 50 percentile value, which is Q2, quartile 2. What is the 75 percentile value?
39.
39, which is 75 percentile, which is known as quartile 3. 100 percentile value, which is also known as max value, is here. 100 percentile, which is max. Now you join 75, 25 percentile values like this, and then you join these max like this. This is known as box plot. A box plot contains 0 percentile, 25 percentile, 50 percentile, 75 percentile, 100 percentile. That is what a box plot contains. Is it absolutely clear? Box plot drawing?
Yes.
Very simple, isn't it? Even though we drawn it for the first time, it's not that difficult to understand. Are you ready to draw the box plot for Y variable? Let's draw. Now, what is the maximum value of Y? Minimum value is 0. Max value is
5 million.
5 million. So can I go by this scale 10, 20, 30, 40 like this?
No,
No.
take millions.
1
We have to-
million, and then 2 millions, and then 3 millions, 4 million, 5 million. Right? Let us draw the box plot for Y. What is the 0 percentile value? 0 percentile value is 0. Right? It comes here. This is 0 percentile. What is the 25 percentile value?
Below 1 million.
Somewhere very near to this. Yes or no? Are you with me, everyone?
Yes,
Yes,
sir.
sir.
Where does the 50 percentile value come?
26 near to the
Very near to this. Where does the 75 percentile value appear?
Near to 0.
Where is the 100 percentile value?
the
It is
5
a
million mark.
5 million. You join all the lines, and this is how the box plot for Y looks like. Is this really a box plot?
It is, but it is not distributed equally, sir. X
This
square
is
or
also
X
a box plot. But why is it looking like this?
because of outliers.
When there are outliers present in the data, your whole box is compressed. This is 75% of the data. Is it fair to say until here 75% of the data is covered? Yes
Yes,
or
sir.
no? Until that point, 75% of the data is covered. Here, 75% of the data is compressed here. So when there are no outliers, when the data is well distributed, the box plot looks like this. When there are outliers, when there are high side outliers, the box is compressed here. When there are low side outliers, the box will be compressed there. Tell me, from here to here, what percent of the data is present? From
50%.
here to here, what percent of the data is present?
50.
10 to 50.
50%.
50%. Until here, 75% of the data is present. Yes or no?
Yes, sir.
So when the box is compressed either on this side or when the box is compressed on the upper side, that means there are outliers present. When the box is well spread from 0 to 25, 25 to 50, 50 to 75, 75 to 100, if it is well spread, then there are no outliers. Looking at the box plot, you can very easily tell whether there are outliers present in it or not. Looking at this box plot, what will you say? Outliers are present or not?
Yes, sir. They are present on the high side.
Very, very less. Looking at this one, are there outliers present?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
So
More.
75 percentile is around 15. Max value is going to 120. Looking at this box plot, what would you say?
Yes, sir. There are many. There are outliers.
Extreme outliers are present, isn't it? You cannot expect always a perfect distribution like this. Can you expect a perfect distribution in the real world data sets? The distance
ideal.
between 0 to 25 to 25 to 50. Perfect distribution, will it come? No.
No.
Most often it may be like this, or it may be somewhat like this. But if it is like this, then what?
There is some
Definitely outliers present in the data. What I want you to do is a simple experiment. There is bank market data. I don't want you to do complete percentile distribution or anything. I simply want you to look at the box plot of bank balance, box plot of age, box plot of bank balance and box plot of age, and tell me which one of them has extreme outliers. Comparatively, which variable has higher outliers comparatively, which one is a better one. Go ahead, observe both the box plots and tell me which one of these two have comparatively higher amount of outliers. It's true that every variable that you look at will definitely have some outliers, but comparatively, which one has higher outliers?
Balance.
Sir, balance has more of.
More outliers? Is it very evident? Is it easy to pick up? All of you? Look at this. This is the box plot for balance. Where is the box? Here. 50% of the data is here, and there are some values that are going extremely high. There are some values that are going even below 0. Is it fair to say, looking at this box plot in one of the written questions, written tests, this will be one of your question. Looking at this box plot, what is your inference? Option A, there are outliers present. Option B, there are no outliers. Option C, we cannot say anything. Option D, there is, like, sometimes there are outliers, or option D, none of the above. What will be your answer in this one?
There are outliers.
There are outliers
are present.
present. Is that easy to pick up? Yeah. Another interview question would be, look at graph 1, look at box plot 2. Box plot 1 is for balance. Box plot 2 is for age. Comparatively, which variable has higher amount of outliers? Can you
Balance
answer that question as well?
Balance.
Yes, sir.
Balance. Looking at a
Balance.
box plot, can you tell whether it has outliers present or not?
Present, but
Present.
Here also outliers present. What Python is suggesting, even though this is the maximum value, these are the suspected outliers. These are the suggested outliers suggested by Python. Actually, this is the maximum. This is the original box plot. But Python is suggesting anything above 70, you can take them as suspected outliers. But for us, we will not take that suspected or anything. We will just directly take this as the box plot. And looking at the box plot, we can say that little bit of outliers are here and extreme outliers are here. My question is simple. Looking at a box plot, can you decide whether there are outliers present or not? Can you do that independently in future?
Yes, sir.
Yes, sir.
Yes.
So
Sir.
as a shortcut, what you can do is, if you have too many variables in a data set, if you have larger data sets with too many variables, draw box plot for all the variables first. Then only shortlist those variables that are having extreme outliers. Then go back to the previous method. What is the previous method? Look at the percentile distribution, do a drill down, find out exactly what percent are outliers, what percent are non-outliers. Maybe you can do this as a first step. But usually what I have seen is people do not really. Yeah, go ahead. Somebody has a question. Question? Okay. Be careful, just go on mute when you're not talking. Just a kind request, because it's getting recorded. Later on, when you're watching the video, it will be irritating. Okay. So what I'm trying to say is, this is a kind of alternative option. This is a kind of easier option, just to look at the data and find out, or look at the box plot, find out whether outlier is present or not. But what I have seen is, in real world, a lot of people use percentiles directly. This is also another alternative option. Have you understood this perfectly, or is it really complex? Will you be able to handle these type of challenges, whether outliers present or not? Can you find them?
Yes, sir.
Exactly
Yes,
what
sir.
percent are
Sir.
present. You can find them, right?
Yes, sir.
Yeah. Later on, I'm going to tell you how to handle these outliers. The next session is going to be data cleaning. In that, I'll tell you how do you handle different, like I'll give you several scenarios that we may face in day-to-day life, and then we'll try to clean them. Then after that, I'll give you a project. In that project, you may get another challenge. Then you will apply whatever you have learned here. That's what makes you a clear data scientist later on. So that is session 1. We have discussed bare minimal basics, very basics, without having the knowledge on mean, median, variance, standard deviation, outliers, percentiles. We will not be able to follow the upcoming machine learning lectures. That's why we have to be very thorough and very confident in whatever we have discussed here. We should not be having any doubt in future that what exactly is mean, median kya hota hai, mean kya hota hai, what is variance. Are you with me, everyone? Have you understood everything clearly in this session, whatever we
Yes,
have
sir.
discussed?
Yes, sir.
Yes, sir.
Yep.
Yes.
All right. Let me stop the recording and then I'll take the questions.